Hey guys, it's DIY Rob. In today's video, I'm going to attempt to fix the on-off switch or on-off button here of my deskjet 4210. Now, I wanted to switch this on and I pushed it a little bit too firmly, and now this button is out of alignment, as you can see. It's not flat, flush down in this recess, but it's now fully bent. So unfortunate, because I should have just paid attention and not put myself in this situation, but maybe this video may be of use to you if your printer has such a problem. So I have to dismantle this, and let's quickly get started. So I looked up some guides on the internet about how to dismantle this printer, and I saw a guy basically pull out this it's held on by clips, plastic clips. So starting from here, up, and here are the clips. 1, 2, 3, 4, 5 clips on this location. Okay, so here is the button. Let's see. Yep, I think it's broken. Let me unscrew this and get even closer. Trusted set of screw heads. And now I'm looking for a Torx. Three Torx screws undone. And this whole panel comes out. And here is a ribbon cable that I just had to pull out. And just keep this up here, making sure it doesn't fall deeper inside the printer. So let's take a look. The button is here behind, and the plastic is broken. I'm going to have to see if I can weld the plastic back or glue it in place. There are some clips here that release the green PCB, this board. Okay, this is the button board. And this is my problem here. Yeah, it's broken. You can see, let me bring you closer. This button was attached to these two pieces here, so that every time that you press from behind to switch on, it flexes up, pushes the button, and then comes back down. So I'm going to have to find a way to glue this back on. And this is just such a specialized part that I don't even think they sell these. Okay, let me just think about what I need to do here. Maybe some epoxy should do, and I'll be back. This is the button that is broken, and you can see it's attached, this button, to these two very slim and flimsy pieces of plastic, and when you push to switch on, this plastic pieces flex to go down and push on the switch. And this is a very big problem, because I need something that will enable me to glue this back together but still remain flexible enough to take that constant pressure, repetitive pressure of switching on and switching off the printer every day. So I think what I have to do is first just use super glue to get the two pieces bonded back together, and then I have to find something else to reinforce the joint, and probably hot glue, because hot glue is one of the few materials that still have some elastic properties when you use it. Still enables some kind of flex. I'm just afraid that the more I push it, the more I continue to make this movement on this broken part. Okay, let me just quickly see what I can do and I'll be back. So first step, just to secure the two pieces back together, I'm going to use super glue. And I could even use super glue and baking soda, just that I don't have much space to work with at the back of the button. Okay, so I have some tissue paper with me, just general toilet paper, and I'm going to try to make a sort of cast. Something that I hope we will get. You can see the tissue paper soaking up the glue. So what I'm trying to do now is just to generate a material that is going to bond and fuse the two pieces together, because I have just so tight of a space to work in. And I'm hoping that this tissue paper is going to get very, very hard once the glue has dried up on it. And this will kind of create the material that just wasn't there before to bond. Okay, I also have to bond it with this small piece of, I think this is acrylic glass or plastic. Now, obviously this is not going to look like the most professional job, but hey, this printer has done its job and served its purpose for so long. I'm just trying to squeeze out a bit more use from it. First I thought about using hot glue, but then I just remembered that on this board here, this is already supposed to rest in like here, like so, and I don't have much room to play with at the back. But by doing this in this way, the paper is just so slim that I'm able to cast a sort of material without actually taking up much room where the button is supposed to stay. Okay, so now I'm just going to align it and just let it rest till it gets dry, and I'll be back. Okay, I'm back. Now I've allowed this to dry. Basically, let me put something on the... Okay, you can see that the paper has dried with the glue on it, so it has become actually a structure of itself, like a small, like some sort of bone. And if you remember, there were just two small pieces of plastic holding the button, the push button here, to the anchor point. And now it's a full-blown cover. And if you see, when I try to flex it, it does still flex a bit, giving me the ability to push down and not crack the joints. So this is going to hold on for some time. I'm very sure of this. It's going to hold, and if it breaks, then I simply repeat the process again. So let's reassemble this, just to show you again. From a bit closer, you can see super glue and tissue paper. Okay, let's reassemble and see if it works. Okay, so this goes in here into these two plastic points. And then I have to put back the printed circuit. And in this case, if you have to be careful not to crack this. If this swells up more than permits this to go back in its place, then make sure you trim this down. You can fire this down, the super glue and paper. Just make sure that you don't crack this PCB. Okay, it's in, held on by the plastic clips. Works perfectly, and because there is just very little travel, there isn't actually much movement possible for the button to be over pushed again. Now there is just very little travel. That's exactly what I wanted. So it looks like this is going to be a stable repair. I found out that there was a hole here, and watching over the video again, which I had to stop, I noticed there were no screws in both these holes. So I just got a small screw from my spare screws bin and screwed this down. I did this because I don't want a possibility where the board lifts up again when I push down. I want this to be very secure here. Okay, so now this is ready. Button works, and we can start installing this back on the printer. Okay, printer is here. I have to reconnect the flexible cable here. Okay, it's in, you can see. Lay this down, and we have 3 screws to put back. Okay. Now this mask is basically held on by clips, so we just push this in. And it's in. Test the buttons. I feel like the buttons are a bit too recessed. You can see the buttons here are just a little bit under the level of the mask. So let me just quickly pause the video and see what's going on under there. So I just noticed what's going on here. As I said before, if there is too much padding and glue and the material in a place that didn't exist before, obviously there is going to be some flexing, because we're trying now to squeeze in a material that wasn't there before. And this means that there is a little bit of a notch in the PCB here, and that enables, you can see, the whole button frame to be able to go in just around 1 or 2 millimeters before then grabbing into the button, pushing onto the button, I mean. So this is what happens. Unfortunately, there's nothing I can do about the button, the main start button here needed to be repaired. What I can do about this movement is to fill in between the frame and the PCB here about 2 millimeters of material. And that is going to prevent the frame from going in, from collapsing when I push the button. So let me just get that quickly done and I'll be back to close off. So I found a cardboard piece, and this has just the 1 to 2 millimeters that I need. So I cut out the piece and I'm going to just place it. I think that was just too wide and it was stopping the button from pressing on the switch. So let's try again with something slimmer. Okay, it works. I just wanted to push from all directions and make sure that this button is actually making contact with the push switch. It works. So now I can screw this back on. This is going to keep this whole area tight. Yes, this works. Okay, all buttons work without the frame collapsing. So let's insert back. Oh, oops, I'm almost losing this. Okay, got it. Yeah, this is how a 1 minute job becomes a 1 hour job when you have to dismantle even more stuff. Okay. It's much better now. You can see the buttons just lightly arched over the frame. And that's it. Repaired. And apart from some scratches on the button that you see on top of it, no one will almost find out that this was repaired. Okay, let me place this back in on the shelf where I usually keep it and test it. Plug it to the electricity and test it. Okay, the printer is now on its shelf where I keep it, and by switching off the light you can see the green, the light of the start button shining through. So if I press and hold, switches off, push one time, it starts, makes all the noises, and that's it, repaired. So the button now feels rock solid and it should hold for many more years. Probably something else is going to get destroyed before the button does. So that's it. I hope this video helps. If you have a push button on your printer that is wobbling around because maybe you pushed it too hard, then now you know basically an idea of what you need to do to get it back online. Okay, thanks for watching. switched off the printer, and take care.